I'm on page 91 of the exercise book, and I've already copied that first problem over to my notebook because we're going to solve this one with graphing. And it says to consider the following linear equations, which description of the solution is true. So I want to graph both lines and see what happens in the graph. And then we'll come back to the questions. I did make a little note there on the first option so I could remember to tell you what I need to. So I'm going to draw a coordinate plane, and we need to graph these equations. Now we don't have any points to graph, so we're going to need to come up with some. And I'm going to take the two equations, let me just bring them down here so I can see them. Got 2x plus 7y is 9. And then we have negative 7x plus 2y is negative 1. So the first thing I'm going to need to do is come up with some points that I can graph. Now, one thing that would be really helpful also is to put these in slope-intercept form. So let me go ahead and do that first. And to do that, I'm going to draw my pattern in there. Remember, the top is what you want it to look like. So let's put that pattern up here, and that will help me to do what I need to. So I need to move the x term over to this side and cancel. So I'm left with 7y equals negative 2x plus 9. And divide both sides by 7. So this is going to be y equals negative 2/7 x plus 9/7. Let's go ahead and do that. That's not going to be equal. Let's not do that. Let's do it as a fraction. 9 divided by 7 is 1 2/7. Okay, so here is that graph or that equation in slope-intercept form. So let's take a look at what this is saying to us. It's saying that the slope of that first one is negative 2/7. So for every 2 that you drop, you run 7. And the y-intercept of this equation is x is 0 always, and then at 1 2/7 it will cross the y-axis. So let's go ahead and try to graph this equation. And let me just bring this up here for the moment so I don't have to keep moving down. All right, I'm going to graph that y-intercept first because that's the easiest thing for me to graph. So over 0, up 1 2/7. So if this is 1, 1 2/7 is about, 1 2/7 would be about right here. Okay, I just learned something very important there. When I touch that line like that, okay, never mind. I did learn something, but okay, there's the y-intercept. Now it says to drop 2 and run 7. So let me do that with the laser pointer instead of the pen. So I'm going to drop 2. Do it this way. From this point, that's going to be hard to do. So here is 1, so about right there, and then run 7. So here, something like that. Now I've lost it. 1, 2, 3, 4, 5, 6, 7. So somewhere about right there. That's close enough. And then I'm going to get a point up in this area also, so I can connect them. So that would be a rise of 2 and a run of 7. 1, 2, 3, 4, 5, 6, 7. So somewhere about right there. And here comes the line that I'm looking for. Something about like that. Now that's a little bit wonky, but it's going to be wonky. No, that's not wonky. That's right on. Okay, so here's the graph of that line. Negative 2/7 slope. All right, so let me bring this back down out of the way. And let's do that same process for the other equation. So here is slope is negative 2/7, and the y-intercept is at 0, 1, and 2/7. Okay, so let's bring this over just a hair, and I'm going to do the same process. We're first going to put it in slope-intercept form. So we want y equals mx plus b. So we need to move the negative 7 by adding 7x to both sides and canceling. So we get 2y equals 7x minus 1. Divide by 2 throughout the whole thing. And we're left with y equals 7/2 x minus 1/2. So for this one, the slope is rise 7, run 2, and the y-intercept is at 0, negative 1/2. So let me bring this up here and put it right here where I can see it. And I'm going to start with the y-intercept. So no movement left or right, but I drop down 1/2. So let's put a point about right there. And then the slope says you rise 7 and run 2. So we will 1, 2, 3, 4, 5, 6, 7, run 2. So somewhere about right there. 1, 2, 3, 4, 5, 6, 7, run 2. And then I'll go the other direction, so I'll drop 7 and run 2 back the other way. 1, 2, 3, 4, 5, 6, 7, run 2. So somewhere about right there. And let me connect these dots and hope. Oh, that was pitiful because it didn't snap to, for one thing. Nope, that's not even close. Let me try one more time. There we go. All right, you're going to notice that these lines are not parallel. They're actually perpendicular. And I could tell you that before I drew it. There's a way to know, and I'll show you that. Lines that are parallel have the same slope, and that's the note that I made right here. These lines are not parallel. They're perpendicular, meaning they're crossing at a 90-degree angle. Let me try to draw that 90-degree box in there. Bear with me. I need a square. Let me trace that one and see what happens. Okay. I'm going to rotate that just a hair, because these are at a 90-degree angle. That is a perpendicular relationship. And I knew that's the case because the slope of the blue line is 7/2. The slope of the red line is -2/7. Those are called inverse slopes. The fraction is flipped over in one, and it's also positive negative. They're opposites. And when that's the case, you're going to have a perpendicular relationship. And that's what that box means. 90-degree intersection right there. That's also the solution to this equation, and we'll figure that out in just a second. But when lines have the same slope, they will be parallel. When they have inverse slopes, they will be perpendicular. That's a very good math rule just to have tucked away in your memory. Okay, let's focus on this point right here. This point is at about the black point that I'm looking at. It's about 1/2 on the x-axis, and then it's above the x-axis at about 1 1/3. Something like that. That's close enough. This is the solution to this system. 1/2, 1 1/3. So let me bring that back over here. 1/2, 1 1/3. And let's see what the answer is going to be. The lines are parallel. No, they're not. They are not parallel. They are perpendicular. So the slope, there is no solution. That is not a true statement. The y value of the solution that we're calling 1 1/3 is smaller than 1/2. That is a false statement. The x value of the solution, 1/2, is greater than 1. That's a false statement. Both the x and y value of the solution are negative. That's false, because both are in quadrant 1. The y value of the solution is greater than 1. That is the true statement. And so I would go with E on this one. And what a problem that is. There's a lot to learn in that problem, though. The thing about parallel and perpendicular is important. But the answer is E. And I'm going to stop this video. It's getting very long.